Hello, my little puddin' pops. I am back. We're going to do an update, and then we're going to jump right in and go over 8.4. Okay, so the structure of this class, whoops, pointer, not that. The structure of this class is going to stay pretty much the same as it has been since I've been gone. We're going to have lecture days, 2 to 3 lecture days per section, depending on how long the section is. Then we're going to have a work day where you do practice problems, review problems, etc., going over the material that we've gone over in the section. Then we're going to have a review day where we go over the work that you did the day before and review any questions or anything you might have had throughout the section. For submitting your work, we're going to go back to submitting your work strictly on Google Classroom. If you want anything graded, it must be submitted on Google Classroom. The due dates and times will be on Google Classroom, and it will either be by the end of the period or the start of the period the next day. It will say it will be one of those 2 times. And my late policy is changing, so rather than it being minus 5% for the first 24 hours late and then minus 5% more, so minus 10% for the next 24 hours, and then not accepting it at all after 3 days, the new late policy is if you hand in something late, if you don't turn it in, let's say we have an assignment due at 9 a.m. If you don't hand it in at 9 a.m., you have until 9 a.m. the next day, so you have 24 hours to hand it in. If you hand it in, let's say this is on Monday, if you hand it in on Tuesday at 8:59 a.m., you're good. It will just be minus 10% because it's within 24 hours late. But if you hand it in at 9:01 a.m., it will not be minus 10%. It will be a 0 because that's more than 24 hours late. So you have 24 hours. If it's late, it's minus 10%. And if you get it in within 24 hours, it will be only minus 10%. But if you don't, it will be a 0. All right. We are going to have reading and lecture notes. You're going to have reading notes the same you've had with me the whole year. And they will be graded using that note-taking in science rubric that you've seen a million times. I'll post it again when you have reading notes due so that you can look back over it if you need to. And then your lecture notes. So you're going to need to take really, really, really good notes starting today. You can either take them on paper or on your computer. You need to take lecture notes over every single thing that I'm talking about, and then at the end of the last lecture, you will submit those lecture notes, and I will grade them based on the notes taking in science rubric again. So, today you're going to start taking notes when I start lecturing over 8.4. You're going to take notes tomorrow, and I should finish either tomorrow or on Wednesday with 8.4. Then, on Wednesday, by the end of the class, or by the start of the class the next day, you're going to hand in your lecture notes, and they're from the lecture, and I'm going to know they're from the lecture because I'm adding some stuff that's not necessarily in the book, or I'm giving you a different explanation, so don't try to BS me and not take any notes on Monday, Tuesday, and Wednesday, and then fake a bunch of notes from the book or something and hand that in on Thursday. I'll know the difference between reading notes or notes from the book and lecture notes. That being said, you need to bring your devices to class because if the lecture notes are due by the end of the period, you need to submit them by the end of the period, okay? If you are misusing your device, that will be a detention. If Mr. Blem sees you using your device to get on or to message someone, or to get on your email when you should be taking notes, or to be doing anything other than what you should be doing on your computer, if he sees it, no questions asked, he can give you a detention if he sees you messing around on your computer. So, use your computer as it's supposed to be used, please. And that you have to bring a device to class. So if you don't have one, you need to talk to Miss Soldana about getting one, or you need to talk to your parents, etc. Okay? Bring your device to class. Finally, your Chapter 8 quiz is going to be on Friday, April 2nd, which is the Friday before spring break. So not this Friday, but next Friday. So that's when you'll have your Chapter 8 quiz. We're not going to be staying on Chapter 8 this whole entire time until next Friday. We're going to move on to Chapter 9. However, that's when your that's when that Chapter 8 quiz will be, is next Friday. All right, so that is it. If you have any questions over any of the things that I've just said, send me an email or a Google comment or Google Classroom comment. Or you can, Google Classroom comment would probably be best, because you might have a question that's similar to someone else's. So just do a non-private comment on Google Classroom. Okie dokie, we're moving on. You did your reading on Chapter 8.4, which is the last section in Chapter 8. This is about polar bonds and molecules. So before we start, we need to talk about this idea of polarity. Polarity. Hopefully you should know what polarity kind of is based on your reading. Polarity is just the property of having poles or being polar. And that kind of is not the coolest definition, since we're using the word to define the word. So another way that you can kind of think about polarity is as the state of having two opposite ends. Two opposite ends. And maybe you know the word polarity from other things outside of chemistry. For example, we have some real-world examples like the poles of the Earth, right? The Earth has a North Pole and a South Pole, right? And we also have another example would be a battery, for example. A battery has a positive end and a negative end, right? So it's polar. Another one that's kind of you might not think of, something like politics, right? The American political system specifically, right? We have a left side, Democrats, and we have a right side, conservatives, right? And they have pretty polar opposite beliefs, right? So we have polarity in this American political system. So I think you get the idea. In chemistry, we also have polarity in bonding and in molecules in general. So that's what this whole section is about. So we can have polar or non-polar, which means not polar, right? Meaning it doesn't have opposite ends. We can have polar or non-polar bonds, and we can have polar and non-polar molecules as a whole. Okay, so these are the two kind of ideas that we're going to look at today. We're going to start with looking at bond polarity and how we determine if a bond is polar or non-polar. Then we're going to look at molecules and how we can determine if a molecule is polar or non-polar. Okay, so we're going to look at bond polarity first. And I want you to recall that covalent bonds involve the sharing of electrons between atoms, right? Covalent bonds are sharing of electrons between atoms. Okay, so covalent bonds differ in how the atoms involved share the electrons. So these bonds are different based on the kind of the strength of the atoms involved in a molecule. For example, if I have a diatomic molecule, let's draw it like this. We have a pair of electrons shared between these two molecules. Okay, so we could have these two, we could have these two electrons perfectly in the middle, right between these two molecules, these two atoms. We could have the electrons a little bit closer to, we're going to call this one the red atom. The red atom, we could have them a little bit closer to the red atom, or we could have them a little bit closer to the not red atom, the white atom, right? So covalent bonds differ in where those electrons are. I drew the last electrons wrong, but you know what I was saying. They differ in where the electrons are between the atoms, okay? So we have polar covalent bonds, and we can just call these, just call them polar bonds. Polar covalent bonds, and we have non-polar covalent bonds. All right. So each of these atoms in a molecule, they can pull the electrons with different strengths. All right. We're going to look at non-polar first. So that's this situation right here. This would be a non-polar bond. Why? A non-polar covalent bond is when the atoms pull on the electrons equally. So when the electrons are pulled on equally. This can only happen when we have two identical atoms. Two identical atoms. All right, so let's think about why that's true. Let's think about atoms as people for a second. So let's say we have Pt.2 here, and we clone her, and we make an exact replica of Pt.2. So there's two Pt.2s. These two Pt.2s are going to play tug-of-war with each other, and there's a flag in the middle of exactly in the middle of the rope. All right, so if these two Pt.2s are playing tug-of-war, and they're clones of each other, who's going to win? Neither of them are going to win, right? That flag is going to stay exactly in between both of these two Pt.2s because they're equally as strong as one another, right? So this is what is happening in a non-polar covalent bond. Let's say we have a hydrogen and we have another hydrogen here. All right, so here are two hydrogens, and they have two electrons shared between them. These two hydrogens are clones of each other. They're equally as strong, so those electrons are going to remain exactly in the middle of this covalent bond, right? So is this bond polar? Remember, polar means that there are two opposite ends. Are there poles here? Is there a pole on this bond? If there was a pole, that means that one end would be partially positive and the other end would be partially negative. But that's not the case in this situation, right? There's no partially positive, there's no partially negative. They're exactly in the middle. So the bond is neutral. The bond is non-polar. If we move, let's go up here, and we're going to have now oxygen and hydrogen. Okay, now let's look at what would happen here. So these are not identical atoms, right? So because they're not identical, they actually have different strengths at which they can pull on these electrons. So those electrons actually are not going to be in the middle. They're going to be a little bit closer. I'm going to draw the electrons as red. They're going to be a little closer to the oxygen. So if we look at the bond, which I'm going to do in blue here, if we look at the bond, those electrons are a little bit closer to the oxygen. So in this blue bond, we could actually split this blue bond in half, and we would see that one side has more electrons. So that means that it's going to be a little bit negative. And the way that we depict that is partially. This is a delta. Delta, it's a symbol. Delta, negative, partially negative. And this side of the bond is partially positive, right? Because it's getting the electrons pulled away from it. So this would be a polar bond, right? So if we compare that to our non-polar bond down here, our non-polar bond where the electrons were exactly in the middle and there's no side that is more more negative or more positive. This would be non-polar. This one is going to be polar, right? So what causes this polarity, this bond polarity? Let me give you the definition really quick here, even though you should probably already have it. A polar bond is a covalent bond between atoms in which the electrons are shared unequally. I'm just going to write electrons shared unequally. Right? They're not evenly pulled by both atoms. So when this occurs, we get a polar covalent bond. The reason that this happens, why does polarity occur? Polarity happens because of this thing called electronegativity, which you should remember from when we were doing trends, and also probably from chapter 7. When we were doing trends on the periodic table, remember that fluorine is the most electronegative if we have the periodic table here. Periodic table. Fluorine is over here. We don't include the halogens when we're talking about electronegativity. Remember, the trend goes electronegativity increases as we go to the right, and it increases as we go up. Remember? All right. So that's what is electronegativity, though? We should talk about what it is. Remind you what it is. Electronegativity is the tendency of an atom to pull electrons toward it. So the more electronegative an atom is, the stronger it pulls on the electrons. So electronegativity is the tendency of an atom to attract, it has two T's, I always spell that wrong, attract electrons towards itself. Okay. So let's look at, now we'll do that in a second. Okay, so the more electronegative an atom is, the stronger it pulls on the electrons. All right? Okay, so next question we should be asking ourselves is, how do we know what atoms pull more on the electrons? Which atoms are more electronegative? Well, we can look at our trend on our periodic table, right? We can look at this periodic table, and we know that as we go up, electronegativity increases, and as we go over, electronegativity increases. But how would you know which one is more electronegative? This one or this one, right? Because this one is higher on the periodic table, but this one is more towards the right. So how do we know for sure which one of these two is going to be more electronegative? We have to look at this table called the Pauling scale. The Pauling scale. We use the Pauling scale, and this was made by Linus Pauling. Maybe you've heard of him before. Pauling scale. And the Pauling scale, I think it's in your book. It's not called the Pauling scale in your book. I don't know if I can't remember exactly if they gave you that word or not, but or that title, but it's the table in your book. And it is the differences in electronegativity between a bunch of different atoms. So here it is. This is the Pauling table. So if you look, we have all of these different values between each different element, and we exclude the halogens, remember, because halogens, they're perfectly content. They have an octet. They don't have electronegativity. They don't want to pull electrons toward them. So we don't have the halogens in this Pauling scale, or the Pauling table. Okay, I'm not sure if this is in your book or not, but I will give it to you on your homework and on the quiz. So don't worry about writing this down or anything. Okay, so here's the scale. So these values are assigned to each different atom based on their electronegativity. So you see fluorine has the highest electronegativity, and down here has these over here we have the lowest electronegativity in general. Okay, so how do we use this information? We need to look at the difference between the electronegativities of two atoms. So let's just do, we're going to look at some examples. Let's look at, first we're going to look at hydrogen bound to hydrogen. Okay, well that one's easy, right? Because if we have two atoms that are identical, they're going to have the exact same electronegativity, right? So the difference between them, we have hydrogen is 2.20 minus hydrogen, which is 2.20, is 0, right? So if we have 0, if you look here, if we have 0, the range is 0 to 0.4. Anything in that range, we are going to have a non-polar covalent bond. All right, so hydrogen and hydrogen together, that's a non-polar bond. All right, now let's look at hydrogen bound to chlorine. Let's look at hydrogen bound to chlorine. Chlorine is over here. All right, so the difference between these two is hydrogen is 2.2. Yeah, you can subtract it like I did the first time. We'll do chlorine because it's higher. We'll do that one first. 3.16 minus hydrogen. It's the lower one, so we're going to subtract it. Right? This is a difference of 0.9. Right? We have 0.96. Okay. All right. So if we look at this table again, we have 0.96. That is here. That's going to be a slightly polar covalent bond. So this is a little bit polar. So the chlorine, because it has a higher value electronegativity value, is pulling those electrons a little bit closer to it than it's pulling them away from hydrogen, a little bit closer to itself, right? So this bond is slightly polar. Slightly polar. All right, now let's look at another example. We are going to look at hydrogen. Hydrogen bound to fluorine. So let's look at fluorine's electronegativity. Right away you should say pretty much fluorine bound to anything is, well, not anything necessarily, but fluorine is usually going to form a covalent or a polar bond. So if we look at fluorine's electronegativity, we have fluorine is 3.98 minus hydrogen's again, which is 2.20. That is a difference of 1.78. And again, if we look down here at our table, we are at 1.78. That's right here, right? So that's a very polar covalent bond. So now we are at very polar. This is a very polar bond. That fluorine, because it's the most electronegative, it pulls the strongest on electrons. So it's pulling those electrons from hydrogen really super duper close to it. Really super duper close. So this bond is partially negative on that side and it's partially positive on this side. This is a very polar. And the reason for that is because of this high difference in electronegativity. Then pretty much if we have anything higher than 2.0, so if we look at NaCl, we have Na here. I'm going to erase some stuff. All right, we have Na right here and Cl, right? So we have NaCl. Cl is 3.16 minus 0.93, which is Na, gives us a difference of 2.23, right? So that is above 2. So anything above 2, that's actually going to be ionic. That's going to be not a bond, it's an ionic interaction, okay? All right. So that's how we use this Pauling scale. This is the Pauling scale. We use this Pauling scale with all these different values of electronegativity on it. And we use this table down here. You're going to have to remember this table. You're going to have to basically remember this little table right here. It's squared. I just put a square around it. You need to know the ranges for differences in electronegativity. And if a molecule within those ranges, whether they're non-polar, slightly polar, very polar, or ionic. All right? All right, so that's where we're stopping today. Tomorrow, actually, we're going to go over all right, so that's where we're stopping today. We're actually not going to go over molecular polarity today because this is kind of a lot of information. So your homework is the document that's on today's assignment on Google Classroom. You're going to answer some update questions and then some 8.4 questions of going over all this stuff that we just talked about. And tomorrow we will continue on with molecular polarity. So the assignment is due tomorrow before the start of class. And don't forget, you have to submit it online on Google Classroom. If you want to do it on paper, that's fine, but you're going to have to take a picture and upload it onto Google Classroom. If you want to do it, it's probably easier to just do it on electronically and submit it that way, but whatever floats your boat. Okay, please let me know if you have any questions, and that's it. You can use the rest of this period to finish your assignment. Thanks.